We're like a group of treasure hunters exploring the unknown, having discovered the dazzling technological trove of the past decade: large language models LLMs. These LLMs, such as ChatGPT and GPT-4, turn out to be like wizards with magical powers, performing spellbinding acts in the world of text, making us marvel at their human-like intelligence. For instance, in the healthcare field, GPT-4 is akin to a savvy librarian with all the medical books in the world's knowledge, analyzing vast sets of medical data to assist doctors in making wiser diagnostic and treatment decisions. Turning to the financial market, these LLMs are like soothsayers of the stock market, delving into the morning dew of the market to forecast the potential rise and fall of stocks. Picture these technological oracle everyday mornings sitting in front of their computers, murmuring mystical incantations and accurately predicting market trends. In the realm of marketing, GPT-4 serves as a psychologist who understands human hearts. It comprehends customer needs and crafts personalized promotional materials. They get to know us better than we could imagine, like a mind detective in the field of marketing. As for education, imagine LLMs as guides with an endless knowledge backpack, designing a learning journey suited to each student. They tailor content based on individual learning styles and paces, carving out a personalized path of enlightenment for each learner. These LLMs, when decoding protein sequences, are like detectives with super sleuthing skills unraveling life's deepest mysteries. And speaking of GPT-4, we can see it as a genius with access to every library in the world, capable of reading text and images, and like a wise sage, handling complex tasks that require advanced cognitive skills. Through this imaginative journey, we hope to make LLMs understandable even to those who are novices in technology. We find ourselves in the midst of a fiery debate about whether large language models LLMs possess consciousness. Picture this: philosophers, cognitive scientists, linguists, and AI practitioners are locking horns in an intellectual showdown more captivating than any real-life man versus machine battle. When it comes to understanding LLMs, it seems there are several different tiers. The reductionist view LLMs much like mathematicians see numbers, convinced that these models are just cranking through numerical operations like solving math problems, without really understanding what they're doing. Also, we have overly simplistic beliefs that assume LLMs must have human traits simply because they communicate using language. However, this viewpoint is too shallow, failing to consider the complexity of true human cognition. And as for whether consciousness requires the biological structure of carbon-based brains, the prevailing view is that language models, being purely computational, lack the intrinsic carbon-based biological feature needed for consciousness. Additionally, some researchers point out that consciousness is tied to specific electrochemical processes absent in silicon-based systems such as AI. If these perspectives are accurate, it could mean that all silicon-based AI entities are incapable of consciousness. But there's a strong counter-argument. Human consciousness and the mind are inextricably linked to the material brain, specifically its neurons, synapses, and other activities. This implies there isn't some spooky separation between the mind and body. The notion that the mind is a mysterious entity existing independently of the brain has been debunked by neuroscientists and philosophers alike. The brain's function is the very foundation of human cognition, perception, and behavior. The mind is not an entity controlling the body from the shadows. It is a byproduct of the brain's complex neural activities. This is corroborated by extensive neuroscience research, which reveals that every conscious experience corresponds to precise patterns of brain activity. Still, in certain philosophical and religious domains, the belief persists that the mind and body are distinct entities. However, such claims are increasingly challenged by evidence demonstrating the inseparable link between the mind and the brain. We often hear about this thing called the Chinese room, a classic thought experiment in philosophy. Imagine one day you walk into a room filled with Chinese symbols and instructions, and even though you don't understand a bit of Chinese, if you follow the instructions closely, you could string together a coherent Chinese dialogue. Outsiders might even be convinced there's a fluent Chinese speaker inside. But here's the rub: while we can follow instructions to make sentences that seem to make sense, does it really amount to understanding the language? Like computer programs responding to Chinese characters, they might answer perfectly but only mimic the illusion of understanding, rather than truly getting it. It's like saying computers learn language, but actually, all they are doing is manipulating symbols by a set of pre-established rules, without any understanding of what those symbols mean. Then there's the way we learn language. It's more than just memorizing words. It's the association to real-world experiences that gives language its meaning. Take the word cat, for instance. It instantly conjures up an image of a cat and maybe some memories of interactions with one. This process is usually quick and unconscious, especially when we race through language. Look at how little kids pick up language. They learn from all sorts of clues around them. Unlike models that only deal with text, they live in a physical world and collect sensory data: sounds, sights, touches. While models are busy spotting patterns in text to understand language, they're missing out on all the context that we take in without even thinking. Some question whether consciousness and understanding really need senses and a body. What if a system without senses, or even a brain in a vat, could still have thoughts? Perhaps an AI system, senseless and bodiless, might still engage in math, ponder its existence, or even reason about the world somehow. The coherence we find in the language data suggests that the models are trained on stuff that sort of fits into a consistent view of the world. While today's language models might not tap into this framework fully, future models might just piece together a rich and complex tapestry of the world. When it comes to how humans learn language, it's more than just the visual stuff babies pick up on. Language learning isn't limited to what we see. It's about all the senses mixed together. Defining what's absolutely necessary for humans to learn to communicate is one tough nut to crack. The traditional idea of grounding in meaning is getting a shakeup from cognitive science. They're putting forward a view that flips the script: representational pluralism, they call it. The idea is that all our concepts come from a mix of experiences and language, but how much each weighs and varies. Take our understanding of the term aardvark. We may know what it means without ever pointing one out in a zoo. Recent advances are pushing foundational models to mix things up, to draw from pictures and actions, not just words. This new breed of model is trying to root its artificial intellect in the practicalities of the world, like organizing a diverse house full of toys and furniture and a 3D playhouse, or coming up with coherent decisions across different scenarios. The takeaway: while grounding is key for tying models to multimodal data, it's not a deal breaker for their usefulness. These language models can be pretty mind-boggling from a human perspective. They lack some of our standard features, but blow us out of the water with one thing they do super well. Trying to imagine what it's like to be them as an agent is a bit of a mind twist, and our gut feelings about these models are probably not the most reliable guide. Whenever we discuss large language models, LLMs, a lingering question hangs in the air. Do these machines learn genuine world models, or are they just crunching surface statistics? Imagine LLMs as math whizzes, tallying up which words are likely to follow others based on vast human texts. Consider the sentence: the first man to land on the moon was, and the model answers Neil Armstrong. Does the LLM really grasp the knowledge of moon landing? Maybe not. They're just estimating the next words based on previous statistical data. Some researchers even argue that LLM's path to human-like understanding is a dead end, since they haven't truly grasped the meaning of language. Essentially, their main job is predicting strings of vocabulary. They might construct sensible sentences at times, but the truth of those statements resonates only with humans who query or feed data to the models. It's like pointing at the sky and imaginatively uttering "flying pig." If your imagination is rich enough, it becomes conceivable. Many large language models make use of a design called transformers, adept at handling long-distance dependencies between words and sentences or documents. Essentially, transformers are universal function approximators, capable of simulating any continuous function with enough data and computing power. This means they can learn the complex patterns in natural language data, such as the syntactic and semantic relationships between words, and use this knowledge to produce cohesive and meaningful text. Some believe that neural network systems like transformers potentially have the capacity to develop profound and stable world models, at least theoretically. If they could predict better, it may mean their performance could climb to greater heights over time. For example, when discussing the New York subway system, a well-crafted model could significantly improve the accuracy of predictions. Current language models still lack a clear global workspace. There's an emerging body of research exploring multimodal language models, which utilize a workspace to coordinate between various modalities like text, images, or sound. To connect these different modules, a lower dimensional interface is needed, much like a global workspace. For us, assigning intentions to human behavior is intricate and subtle. The basic cognitive elements necessary for intentional behavior remain unidentified, which complicates determining the standards an artificial intelligence system should meet to display intentionality. Future language models might show intentionality through mechanisms yet to be discovered. Despite this, the versatile abilities of language models provide some initial support for this concept. Although there's still some distance from human intelligence, their capability in areas like writing poetry, playing games, answering questions, and offering advice indicates they've taken strides toward consciousness. In our deep dive into the capabilities of large language models (LLMs), we've stumbled upon four pivotal inferential knowledge pillars: formal reasoning like puzzle solving, comprehensive world knowledge from the bits and pieces of life's encyclopedia, situation modeling, which is akin to knitting stories from a yarn of words, and social reasoning, where understanding the unsaid in conversations is as important as the spoken words. Currently, many LLMs can't quite keep pace with humans in these areas, which can make our silicon friends come across as a little bit, well, oblivious at times. So, what paths lie ahead as we seek the holy grail of true language understanding? Spoiler alert, it's not just about supersizing the models. We need to get better at seeing through their smoke and mirrors. The trick of convincing linguistic output isn't enough. The real deal will come from meticulous tests on datasets that tease out the model's knack for specific nuances of language. Think the big bench, beyond the imitation game benchmark, which is like the Olympics for LLMs. Beefing up LLMs with world-in-a-box experience will require more than just feeding them the internet. It involves giving them a sharper edge. Think of a Swiss Army knife rather than a blunt spoon. Models like Minerva and ChatGPT are already upping their game by scarfing down smarter data and getting a sprinkle of reinforcement learning with a side of human feedback for that extra zing. Language isn't a one-size-fits-all t-shirt. It can't cover all the knowledge curves. It's all due to a thing called reporting bias, when you assume everyone knows you love coffee, so you never mention it. But hey, not everyone has been to your kitchen. This is like the party rule that you don't want to bore people, but you don't want to leave them puzzled either. To truly measure how well our LLM buddies handle language, we need a scoreboard for both their grammar game and their chat savvy. This clear scoreboard will help us root out misconceptions like a silver tongue doesn't always mean a sharp brain, and a dull brain doesn't always lead to a clumsy chat. Now, it's become clear we might run out of quality language data faster than your phone's battery on a busy day, maybe even by 2026. But if LLMs can start spinning their own yarn of text, they might just keep the data party going. Like a chef crafting a new recipe from leftover ingredients, LLMs could whip up fresh questions and answers to school them. The idea that LLMs scribbling their training notes might seem like a dog chasing its tail, but think of it more like the brain's daydream, taking what we've seen and spinning new tailies. And bonus, self-improvement might prevent the looming famine in the data feast. With the buzz around AI replacing search engines, there's this fantasy that ChatGPT could become the new oracle for humanity. But let's be real, it still sometimes dreams up books that don't exist and fluffs up explanations. The quest for AI truth-sayers is pushing them to check their facts with the outside world before they spill the beans. The future whispers of LLMs getting juiced up with powers to read, write, and run around the web. These next-gen language models might just have what it takes to bag groceries, book tickets, and maybe even write love letters. Hold the cheese, please. You heard it here first. Agentic AI might be the next buzzword on the digital street. Large language models, our latest chatbots, are shaking things up in AI, teaching machines to gab and gabble with human-like flair. The tussle over whether they've got a jot of consciousness is still the talk of the town. The jury's still out, but it's no secret these digital brains have untapped potential waiting to be unleashed. As we unravel their language-spun wizardry and ponder the morality of possibly conscious machines, the horizon gleams with the promise of tech that not only talks the talk, but might one day walk the walk.